Here we have the total sales in millions of dollars, and eventually we call that S of t. And the total sales in millions of dollars is a function of time in years since 1980. And since there's a t in the parentheses, that indicates to me that the input variable of choice is t. So we are to find the total sales of the company 2 years after 1980 with an equation, and we're going to get that equation by using the process of regression. And then we write our answer in function notation and round our answers to 4 decimal places. So if you do this, you turn your calculator on and go to the stat key, and I want to edit a list, so I'm just going to press enter. Now if you have old data in there that you need to delete, simply just press delete and it will get rid of them all. As you notice, I already put the data in here. So you can delete data just by highlighting the data and hitting delete. And then just type in your x value, 0, enter, 5, enter. And you may want to pause the video and do this because I already have the data entered into my second column there. When you get down here, if you have no data over here, pressing to the right arrow, for me it just goes over here, but if you have no data, when you press the right arrow, it'll pop all the way to the top if you have an empty list, and then you proceed to type the rest of the data in. So I am going to find a linear equation for this, and I'm going to press stat, and I'm going to write it over to calc, and I'm going to select option 4 for my regression. And on the older calculators, you can just press enter, and the default is that it assumes that your inputs are in L1 and your outputs are in L2. How you change that depends on the calculator. Either press enter many times if you're on the 84, or you can down arrow over to calculate and just press enter. So here are my coefficients of 0.0394. If you rounded this to the 4th decimal place, then I would round up because of that digit of a 5. And then my b value to 4 decimal places is 1.2594. Since the 5th digit is an 8, which is bigger than or equal to 5, I round the 3 up to a 4. So 0.0394 and 1.2594 to 4 decimal places. So it's going to be S of t. Instead of writing y equals mx plus b, I'm writing S of t instead of y. My slope was, the calculator used a instead of m, but to 4 decimals it was 0.0394. And for b, the calculator said that was 1.2594. So to 4 decimal places, these would be my coefficients, and that would be my linear equation. Now it says, use your graphing calculator to generate a scatter plot of the data and the regression line on the same screen. Use an appropriate viewing window. So an appropriate viewing window would be simply to put my x min at 0, and my x max would be, the biggest x value would be 26, and then my smallest y value, my y min, could be, you could write 1.19, or if you wanted to go to the left you could write 0 or something, and then your y max has to be at least 2.38, but you could go higher and say 3 or something. There's actually a button on the calculator I'm going to show you that sets the window for you automatically, but only if you are working with data. So I'm going to go back to my graphing calculator, and most of the newer calculators, in fact I think way back even to the 83, if you just press y equals, if you look up here it says plot 1, plot 2, plot 3, I'm going to go up and press enter. That'll turn my plot 1 on. Now if you're ever wondering what the settings are there, you could press second y equals to the stat plot and it would tell you that your plot 1 is on. And if you pressed enter, it would even give you more details. It would say plot 1 is on. The type of scatter plot you're going to get is exactly that, just a scatter plot, as opposed to connecting the dots or bar graphs or box and whiskers or any of that stuff that you may or may not be familiar with. My inputs x are in L1. My outputs y are in L2. You could change that right now. You can see the L1, the L2, the L3 down here as second functions of these buttons down here that I'm pointing at. And then it just is choosing to use squares to mark the dots as opposed to any other symbol. So I said I was going to show you a button that you can press. It's zoom 9. If you press the zoom key, number 9 is zoom stat, and it sets an appropriate viewing window. There is an overall linear trend here, and it wanted me to plot it. If you look at the directions, it said to generate a scatter plot, which I did, and the regression line on the same screen. So you may have automatically put your regression equation into y1, but since I was told to round to 4 digits, it wouldn't be that difficult to just manually type in my regression equation. So there's my equation with coefficients out to the fourth decimal. Now when I hit graph, because my plot 1 is on, you'll notice that the scatter plot's still there, and then I'm graphing what's called the line of best fit. So I did that. I can check that off. Here we were to find an equation. We did that. Here we were to use a calculator to graph it, and we did that. I guess since you're writing things down, you could emulate this. I would make sure to label the x and the y-axis according to the x min and max and y min and max. Now we are to actually use the regression equation. That's the whole point of finding an equation, is to use it to determine values inside the data set and outside the data set. So I'm on this one here. Use the regression equation, that's this guy, to determine the sales in 2008. But if you remember right, you don't actually put in 2008. Oh, I just saw an error. So I used x right here when it was supposed to be t. So I'm going to write this down, my regression equation, and where I see the letter t, I'm going to just put a blank here. There's my input variable. And we are to plug in some input variable to represent the year 2008. But if you remember right, this isn't the year. My input t is years since 1980. So it would take 20 years to get to the year 2000, and then 8 more to get to 2008. So I'm thinking of 2008 as being 28 years since 1980, and I'm just replacing t with 28 here. And if I did that, I'm going to have to go to my calculator to see what the output would be. But remember that my output would be in millions of dollars, and we are to round our answer to the nearest hundred. So 2 decimal places on the calculator. Let me press second mode, which will quit to the home screen, and I will just type 0.0394. I'm using the rounded version of the regression equation to determine my answer. So if your answer differs, it might be because I'm using the rounded version. And I'm going to add 1.2594. So here it is. I'm going to press enter, and it says round to the nearest hundredth. So the hundredth place is the second decimal, right? This is the tenth place. This is the hundredth place. To the thousandth place, since that digit's less than 5, I'm not going to round this up. I'm just going to say it's 2.36. And then if you input 28 years since 1980, the output is 2.36. But remember, it's sales in millions of dollars. So you could just write million dollars, and I think that would work. That is the sales in millions of dollars in the year 2008. So if you want to write a sentence, it didn't ask me to, but in 2008, sales were $2.36 million. Because these units are already in millions of dollars, you have to be careful here. It says use the regression equation. This time they're not going to give me the input. They're not giving me the year. In fact, they're saying determine the year. You know, you find t, so that my sales, which is my output, comes out to be 3 million. So here would be a common mistake. So if you replace the output with 3 million, it would be like putting the number 3 million up here in this chart. And what that would mean is that sales are $3 million, which happens to be 3 trillion. You don't want to do that, because the question isn't when will sales be 3 trillion, it's when will it be 3 million. So you need not put all those zeros. The idea is, since my outputs are already in millions of dollars, simply putting the number 3 means that. If S of t is 3, imagine having a 3 here, you would say if the output's 3 that means $3 million. So when you actually go to solve the equation, you don't actually write 3 million, you just write 3. So now I need to solve this equation. So to solve the equation for t, I would subtract the 1.2594, and I would do it on both sides. I'm going to type in what is 3 subtract 1.2594. I get that answer to be 1.7406. So on the left-hand side, I get that it's 1.7406. This would simplify out. Whenever you take a number and subtract itself, you get 0. So on the right-hand side, I would only have left the 0.0394t. Now, because this is multiplication in here, to isolate the t, I would have to divide both sides by 0.0394. And again, I am not going to attempt to do that. Imagine if I made the video where I do this long division, and it would be a mess. I'm just going to take the calculator. Since this was the last thing I did, I need only hit divide by, and it assumes I'm talking about the previous answer. Take the previous answer and divide by 0.0394. Notice I didn't tell it previous answer. All I hit was a division symbol on the calculator, that button, and it put it there for me. I'm going to round to the nearest hundredth. I would say because that third digit is a 7, I'm going to round that up to an 8. So 44.18. So I get T is approximately 44.18. Now this is the kicker. What is that? What are the units on that? It's a T value. It's years since 1980. In fact, since it's years since 1980, having a partial year, I'm just going to discount that and just say it's roughly 44. So it's 44 years after 1980. So imagine 20 years after 1980 would be the year 2000, and then 24 more would be the year 2024. If you didn't catch that, all I did was take 1980, and I need to figure out what year it would be if it was 44 years after that. So I just added 44. So it would actually be the year 2024, and I will write this over here.